When a function has a constant rate of change, meaning as you increase your input, the output increases always at the same rate, doesn't change how fast it grows or decreases. We call that a linear function. And when we model things with linear functions, we call them linear models. So the general form that we use for linear models is this: y equals mx plus b. This is just the equation of a line. M is the slope and b is the y-intercept if we were graphing it. In the context of applied problems, the slope is the rate of change. It's the change per unit change in x. And b is the initial value, meaning when x is 0, what is y? So let's look at an example. A special discount telephone company offers customers the opportunity to make long-distance calls by paying a 39-cent connection fee and 3 cents per minute used. Write a function model for this telephone company's long-distance charges. So we've got y equals, and then we have the rate of change times x. This is the going to be the cost per something. In this case, we've got 3 cents per minute. Okay, and so we have a 0.03 times x, and then plus the initial value, meaning what's kind of the fixed amount that no matter what is going to be paid. And that in this case is the connection fee of 39 cents, so 0.39. Now that we have that, we can calculate the cost of a 25-minute phone call. We plug 25 in for x, 0.03 times 25 plus 0.39. And now we can go to compute this. The 0.03 times 25 is 0.75 plus 0.39. And that is 1.14. And so the cost for a 25-minute phone call would be $1.14. We want to draw a graph of this function. So here, the axes are bolded a little bit more than the others. So here we've got our y-axis, and here we've got our x-axis. When x is 0, okay, y is 39 cents, 0.39. Again, that was the connection fee. That's the initial cost. And so that's when x is 0, we're going to have our 39 cents. Now, it doesn't really matter how we scale this, is just as long as everything can fit. And I'm going to go ahead and go by 10-cent increments. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.8, 0.9, 1, 1.1, 0.2, okay? And our x-axis will go by we got to get up to a 25-minute phone call if we want to plot that point. So let's go ahead, and we want this to be 25 over here. Let's go ahead and go by 2s. Okay, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. And now we can start plotting. Now, we know that when x is 0, just our connection fee is 39 cents. So that's going to be right up there, right almost at the 0.4. And we also know that for a 25-minute phone call, it's 114. So that's going to be up right around here. Okay, so those are 2 points that we know, and this is a linear model, so it's just a line. So we can just connect those with a line. And of course, that continues on forever.